Assalamualaikum, this is INTSER Ahmed, and our project is reducing fraud claims in insurance industry. So let me straight go to the diagram. So we have a client that will be asking for insurance and basically register from and documents and transferred and also pay fees. So the system, the other side that will be generate a new user ID and also do the verification and also create a smart contract between them. So in the case of that, we have built something similar. So here's the code for that. Let me just. Yep. So there is a struct that is record that is in here we have like id, price, signature count that will be counted. I mean, it will be signature by two parties. One is hospital admin, another one is lab admin. So only these two parties can sign the contract, and the other party is actually the patient itself. So we have the parameter called date and hospital name and value, a Boolean parameter, and yeah, mapping. So we have a mapping to show the records, a particular record, and we have the sign only. This modifier is only valid for only hospital admin and lab admin. Otherwise, you will be not authorized to sign the smart contract. So we have another modifier that it will be check authentication before sign. So when someone try to sign in, they need their records ID and the address. Uh, these are the required parameters. And to validate a record, we need the record ID. If it is not validated, then it is already exist in the system, blockchain system, yeah, blockchain blocks. So for creating a new record, we have a new record function. So this has the parameter of ID, which is then we have name, date, then hospital name, and we have the price. The price of the smart contract, I mean, price that will be written in the contract, and these are the parameters that is required to create a new record. And we have the function of called signed record that is used for two parties to sign in. And if the two parties signed, then the client is will able to claim the insurance. So to test this, we have run Ganache CLI. So we have actually hard coded to test it. Actually, there we have hard coded the lab admin address. This is the address account for the lab admin, and we are actually testing it from the remix IDE for the hospital admin. So from this, we just randomly choose one address and actually compile this code to remix ID, then connect with it. And also from Ganache CLI, we hard coded this value for the lab admin address. And yeah, that's it. And for the patient, we just use it to sign in here. Any other? Yeah, just use the private keys here, and it will be visible actually in the MetaMask here. Fine, sorry. Yep. So for the hospital admin, we have another account. So you can just import. We just basically from the Nudge CLI, we just from the this 10 address and 10 private key, we just imported 3 1. First one is for hospital admin address, and the second one we have chosen for the lab admin access. The third one we have chosen for the patients. So another word we can call it client. So yeah, so that's kind of it. I'll pass it to my group mate. Thank you. Assalamu alaikum.
Ahmed, Matric 1912485. So my groupmate has already explained thoroughly about what our project is and what we aim to solve. So I will just briefly go through the important parts and highlight them again, and how we sort of tackled it using our system. So at first, the primary concern for our system is to detect fraudulent behaviors when it comes to insurance. It is a very common thing that happens in this world. So in order to tackle insurance frauds, in order to detect which systems are or which transactions are fraudulent, it is much easier to understand it using blockchain. So for our project, so these are the structures, our parameters that we have, which is already explained by my group member. So I'm just going to briefly touch up on the modifiers that we have. So the first one, of course, is going to be sign only. So for this, it's going to be for the lab admin as well as the hospital admin. So the people who are not authorized, they won't be able to sign in. So when they are not being able to sign in, we will be showing them this message. For that, and then afterwards we have the authentication system, so which sort of checks which records does exist and which does not exist. Lastly, we also have the validation records. So this modifier, what it does is it checks whether there is already an existing record, or is there something new. So this allows us to check which records are new, which are being created, and it also allows us to see which already exist. So for migration, the migration is pretty simple. So constructor for the owner. So what it does is if it's restricted, we will showcase some messages. If the person is not restricted, if it is completed, then the last complete migration will be updated, and then if or else it's gonna be upgraded to like migration upgraded equals migration new address. So basically what it does is it changes the previous migration to the current one. So that is the whole purpose of the migration part. And so yes, since my groupmate has already explained the whole thing, I will not be adding or repeating the same thing. For our Ethereum part, as mentioned by my groupmate, it's already hard-coded. This was actually done because we had some issues regarding our MetaMask. So I was able to insert Ethereum in my MetaMask for testing, but my groupmate was not able to import Ethereum. So that was actually the reason why we hard-coded Ethereum over here, and that's how we used to test the system. That is all. Thank you.